All right. So on number 75, where we left off yesterday, they asked which figure can have the same cross section as a sphere. Well, a sphere is unique because what's the only type of cross section a sphere could have? A circle. So looking at the shapes there, which is the only one of those shapes that can produce a circle as a cross section? The cone. All right. If we did a horizontal cross section of a cone, it should be a circle, same as its base, right? Or at least similar to its base. So it's going to be sorry, not A, it's going to be B, which is the cone. On 76, the cross section of a right triangular pyramid created by a plane cut through the point shown and is also perpendicular to the opposite base. So if it went straight down to the opposite base, and we, oops, that was a horrible line. What shape does that give us? Not going to be a trapezoid. It is a right rectangular prism. So it's going to be a rectangle because all of these would be right angles since it's a right prism. So it should be rectangle. And again, it said which is the most specific name. So yeah, parallelogram does technically work, but again, a little more specific than that is a rectangle. All right, on number 77, a circle has this equation. So this is our equation in general form. The equation of a circle that we want, and I'll write it up here at the top, is in the form x minus h squared plus y minus k squared is equal to r squared, where h and k is the center and r is the radius. All right. Now, of course, this review, for some reason, number 77 starts off with the hardest type of question that we have on these. And this is one where we have to do completing the square to get it into our other format. So let's just get it out of the way. We have this equation we need to rewrite so that our x values are together. So x squared plus 4x plus blank. And the reason why we're putting a blank is we're going to complete the square for the x values. That's why the blank's there. And then the y values come next, plus y squared minus 10y plus blank. Again, we're going to complete the square. And then equals 7 plus blank plus blank. We have those two blanks on the other side because of the two blanks on the left side. Anything we add to the left, we have to add to the right to balance our equation. So first, what goes into these blanks? All right, so complete the square for the x's. You have to take the middle term and do what with it? Middle term, the b value, divided by 2 and square it. So here, the 4, we're dividing by 2, that is 2. 2 squared is 4. So that goes into that first set of blanks on both sides. Now our x values, this is a perfect square trinomial. Do the same thing for the y's. So I have this negative 10. 10 divided by 2 is 5. 5 squared is 25. So 25 goes into my blanks to balance my equation on both sides. And now on this side, these make up a perfect square trinomial for the y's. So what happens next? I take those perfect square trinomials and I unsquare them into two binomials that are squared. So we have, for the perfect square trinomial, to move it back to a binomial that's squared, we're taking the square root of the first term, square root of the last term, and the sign from the middle. So x squared, what's the square root of x squared? X. What's the square root of 4? 2. And the sign from the middle is a positive. That's it. Again, square root of the first term, square root of the last term, sign from the middle. Same thing here. So square root of the first term is just y. Square root of 25 is 5. And the sign in the middle this time is negative. So we have the first half of this equation. The other side of the equal sign, we're just combining all these values, which all those add up to 36. So what is our radius? What is our center point? Well, for the center point, again, we're pulling out these values of 2 and 5, but we have to make sure that we change the sign when we pull them out, because again, in the original equation, we have negatives. So this is going to be, for our center point, it'll be -2 and a +5. And then our radius, this is our radius squared, the 36. We have to square root that, so we just get 6. So which one's our correct answer? Option B is the correct answer. All right, on the rest of the ones that deal with circle equations are a little bit easier. They just go straight into plugging into our other format. So 78, this one we're just plugging straight into the equation. So substitute the H and the K out. So again, this is our H, this is our K, and this is our radius. Plug them in. So parenthesis X minus 3 squared plus Y minus 0 squared equals 3 squared. Now, is your final answer or option probably going to look like that? No, they'll probably simplify it a little bit. So they'll probably leave this one alone. But the Y value, since we're subtracting 0, they'll probably just put it as Y squared. And for the radius squared, they'll probably square that, which would give you 9. So if you're to find this on a multiple choice, this is most likely what you find as your answer choice. All right. Going over to 79. 79, still dealing with the equation of a circle. This one, a little bit tricky because you have to find some other information first. They give you the endpoints of a diameter. Again, we need to know where the center is and what our radius is. So given the endpoints of a diameter, we're going to have to find the midpoint, which will give us the center. So we're doing the equation for midpoint, which is the average of the x's. So 1 plus -3 divided by 2. And the average of the y's, 3 plus 1 divided by 2, which gives us 1 plus -3 is -2. -2 divided by 2 is -1. For the y's, 3 plus 1 is 4. 4 divided by 2 is 2. This is our center. That's our H and K value. Now, the radius. The radius is the distance from the center to the circle. So it doesn't matter which one of these points you use, but we're going to use our circle formula, which again is X minus H squared plus Y minus K squared equals R squared. We're going to plug in our H and K values and then pick one of the 2 points that they have at the top and use them for X and Y. That way we can solve for R. So I'm going to use the first set since they're both positives. I'm going to plug in 1 for X. I'm going to plug in my -1 for that H value, which becomes +1. I'm going to plug in the Y value of 3. And I'm going to plug in the K value of 2. And that's going to equal R squared. So 1 plus 1 is 2. 2 squared is 4. Then we have 5 minus 2 is 1. 1 squared is 1. 4 plus 1 is 5. And we get R squared. Do I actually need the radius? No. They want me to write the equation of a circle. So I can just plug the 5 in for the R squared. So plugging it back into my formula, this time without the X and Y. So X minus plus 1 squared plus Y minus 2 squared equals 5. Again, we're not squaring it because that is already R squared. On 80, same idea. Actually, from what we did right here, from this point on, this is what we're doing over here on 80 as well, plugging into our equation. We have a point to plug in for our X and Y. So plug it into the equation. We have 4 minus 1 squared plus 7 minus 3 squared equals R squared. 4 minus 1 is 3. 7 minus 3 is 4. Now, before I even do this, you might recognize, does anybody know what the last number is going to be? It's going to be 5. You see the pattern there? We have a 3, we have a 4. If you know your triples, you might be like, oh, my answer is 5. Right? Because, again, these are like the 2 sides of a triangle. when we're plugging into this formula, because it's based on distance, the length of between the x's, the length between the y's. So it is 5. Let me go ahead and finish it though, just so you can see we have 3 squared is 9, 4 squared is 16, and then we still have r squared. Add those together, that's 25. The square root to get r by itself is 5. All right, let's go on to the next one. For this one, it wants to know what coordinate would make a square. Again, I would always recommend, if you're given a problem like this, sketch a graph first so you can visualize what this looks like. Now, this one is mostly in that first quadrant there, so get a lot of space to that first quadrant. We have points of A at 3, 6. So 1, 2, 3, 1, 2, 3, 4, 5, 6. So this is going to be A, and that point was at, again, 3, 6. Then we have B at 5, 2. So 1, 2, 3, 4, 5, 2. So this is B. That was at 5, 2. Then we have C is at 9, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Up to 4. 1, 2, 3, 4. So that's C at 9, 4. All right. D then has to be somewhere over here, right? Somewhere up in this area. Now, we can do this a couple different ways. Easiest thing to do, we can look at B and C and see, all right, well, to go from B to C, how many units did I go over and how many units did I go up? Well, from 5 to 9, I went over 4 units. From 2 to 4, I went up 2 units. So now I follow that same pattern to get from A to D. So increase 4 for my X, increase 2 for my Y. And my other point should be at, so 3 plus 4 is 7. And 6 plus 2 is 8. So my new coordinate should be at 7, 8, which is B. So again, draw it out. Drawing it helps. All right, on 82, what type of triangle has vertices at these points? Again, helps if we can visualize it. So draw a graph. All those points are positive, so we can draw just the first quadrant. We have a point at 2, 1. We have another point at 2, 5. We have a point at 4, 1. And look at this triangle. What type of triangle is that? That's a right triangle. Now, again, if we didn't know for sure it was a right triangle, we might double check. We could have actually found the slopes of those two lines to see if they were opposite reciprocals. If it wasn't a right triangle, then it got a little tricky. You'd have to do distance formula to find the length of each of those sides and use Pythagorean theorem to figure out which one of the other triangles it was. So again, going on to, all right, this one I left my answers up from last class. I actually didn't like either of these questions because the proof is horrible. It skips a lot of steps. First, it gave us all that given information up there. It didn't even state that in the proof. It just jumped straight to saying, we're going to use Pythagorean theorem to find the length of those sides. So it's a bad proof to start off. But they found the lengths of the sides using Pythagorean theorem. You could have also said that you use distance formula to find those lengths. That would be acceptable as well. Step 3, they said they did substitution. Again, I would have preferred seeing transitive over substitution because if you take two things that are equal and then set them equal, that's usually transitive property. Yes, it's a type of substitution, but that'd normally be transitive. 4, I'm fine with. They changed from the equal sign to a congruent symbol. Anytime you go back and forth between equal and congruent, it's going to be some type of definition of congruency. If you want to be more specific, in this case, they had segments, definition of congruent segments. If they had angles going back and forth, they could have said definition of congruent angles. But again, some type of definition of congruency. Then on 5 and 6, I agree with what they did. We had a parallelogram to start off. So the sides that were opposite those two would have had to been congruent because opposite sides in a parallelogram are congruent. That's one of our properties of a parallelogram. So that's true for both 4 and 5. 6, oh, sorry, not 4 and 5. That's for 5 and 6. But then on 7, they went straight to saying we have a rhombus. I don't like that. There should have been a step in between, because in order to say it's a rhombus, all 4 parts have to be congruent. They never stated that as one thing. So they should have had one more line in between saying all 4 parts are congruent. And we could have said that because of transitive property. So like I said, I don't know who from the district made this review, but their proofs have not been the best examples, unfortunately. For 84, the reason why I left this one up there, I didn't like it because, again, there's 2 answers. We could have made a triangle one of 2 ways. First, I graphed the points that they gave us. All right, I graphed these 2 that were in this quadrant down here. Let me use a different color to highlight them. Actually, let me use the highlighter. So I have this point and this point. I graphed them. Great. Then I found the difference in both the x and y so that I could find the slope of that line. So to make a right triangle, I would have to then have a line that was going to be perpendicular to that so that we can have a right angle. So we flipped it, which is why I have the 2/3. But then what point is the right angle? Is it the vertex B or is it the vertex C? They didn't tell us. Since they didn't tell us, we could have gone off either one of those. If we went off of the one that was at -3,4, which was B, and I followed that slope of 2,3, and I kept going up 2/3, up 2/3, up 2/3 until I got to this point, I could have a right triangle that would look like this with my vertex at B. But if I went the other way and went off of this angle, or this point, which is C, I could have kept going up 2/3, up 2/3, up 2/3, up 2/3 until I again hit this line at 3. It would have been way out there, but it still would have been a right triangle. So you had 2 different values of +3 or +9.5 as answers. So if you did either of those and got either of those as an answer, great. But those could have been our answers. If this was, say, a multiple choice on a test, which I would think this one would probably be more like a multiple choice question, you could also use those values and find slopes so that you can figure out which slope was opposite reciprocal. So there's other ways you could have done it. Oops, I didn't mean to do that. Switch back to pen. Hold on. There we are. Okay, on to the next one. So now on 85, the equation of a line containing one leg of a right triangle is this, and we have our slope here of -4. Which of the following equations could represent the line containing the other leg of the triangle? Well, again, they have to be opposite reciprocal slopes. So if the original slope was -4, opposite reciprocal would have to be positive 1/4. So how do I get positive 1/4 on any of these? It is option B. It's the only one that has the correct slope. On 86, this one actually gives you a drawing. And it says it is graphed on the coordinate plane. Which equation represents the altitude of the triangle from vertex B? So B is up here at the top, and altitude is going to come down to this other side, and it's going to have to be perpendicular with AC. So first thing we have to figure out is, what is the slope of AC? So using our equation for slope, so the slope of AC is going to be found by doing the change in y over the change in x. So C has a y value of 2 and an x value of 9. A had a y value of 3 and an x value of 2. So plug them into our slope formula. 2 minus 3 is -1. 9 minus 2 is 7. We need to have a slope that's opposite reciprocal to that. So if we flip and change our sign, we're now at +7. So the first 2 equations are out right away. As for what is our other coordinate here? Well, this coordinate is pretty far down there. It's way off of our graph. If I kept drawing it, it would be way down there. So either of those look plausible. We need to figure out which one is correct. Well, we have a point on the line, that is point B. So take B and plug it into C and D, see which one works. So we have 8 equals 7x minus, oops, sorry, not x, we plugged in 5. Fix that. Plug my value in there. I forgot my value. 7 times 5 minus 36. Well, that's 8 equals 35 minus 36. Well, 35 minus 36 is -1. Does that work? No. So guess what? My answer must be D at this point. But if we want to double check and make sure, do the same thing. Plug it into that equation. 8 equals 7 times 5 minus 27. This time we have 35 minus 27, and 35 minus 27 is 8. So D is the correct answer. On 87, all right, we have a couple lines. They want us to write the equation of a line for this. And for both of these problems that we're going to be doing on this page, we can use point slope form of a line. Now, point slope form is one of the equations that they're giving to you on your reference sheet. So that is y minus y1 equals m times x minus x1. That's the format that we're going to write in for these, because we have points for our lines. We have slopes. Well, on 88, we have a slope. On 87, we have to find a slope to begin. So they want us to do Q and M. To do that, though, we first have to recognize Q and N are parallel. And we have 2 points on N. So we're going to use N to figure out our slope to begin. So the slope of N can be found by doing change in Y. So for that first point, we got 4 and 4. So changing Y on top, changing X on bottom. The other one, we had 1 and a -1. So the Y value was -1. So that's going on top. X value was 1. That's going on bottom. 4 minus -1. Well, that becomes plus a positive. So that's 5. And on bottom, 4 minus 1 is 3. So for slope N, we have a slope of 5/3. That means that the parallel line would have the same slope of 5/3. And the perpendicular line would have a slope of -3/5. So we have this 1 point, which is 2, 6 for both lines Q and M. So that's going to plug into our equation. So we have Y, this is for, I should say, line, let's do M first. So for line M, Y minus 6 equals the slope for line M, we said was -3/5, parentheses, X minus 2. The other equation for line Q, it's the exact same thing except the different slope. Y minus 6 equals 5/3 times X minus 2. Those will be our 2 equations. On 88, so they said a parallel line to this. So they gave us this slope. We have points that we can use for X1 and Y1. So all we need to do is flip that slope so that we now have a -9/4. Oh, whoops, sorry. No, I lied. It said parallel, my bad. So it's going to stay 4/9. And my slope on this one will still be 4/9. Plug it into the equation. Y minus Y1, 4, equals M, our slope was 4/9, times parentheses, X minus, the X value was -4, so that becomes +4, and that's our equation. All right. On 89, they want the length of the mid segment for MN. To find that length of mid segment, normally do the average of the 2 bases. Well, on this one, it's pretty easy to find the length of the 2 bases. We have the bottom one goes from 0 to 15. It's a horizontal line, so the length is 15. On top, the length of this one is 5. What's the average of 15 and 5? 10. Now, if you need to actually work that out, we can work that out. 5 plus 15 divided by 2. Divided by 2 is 10. On this one, you could actually get away with counting the spaces as well. All right, on 90, we have a directed line segment. PT has endpoints. All right, so we have Draw a graph again. We have points at -1, -2, 1, 2, +1. And we have a point at 4, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. And that's T. 4, 7. All right. It wants a point J that divides this segment into a ratio of 2 to 1. Well, first, let's figure out how many units we go over and up. Well, we went 6 units over. We went 6 units up. So if we're going in a ratio of 2 to 1 and we're going 6 units, well, let's double this because 2 going over 2 and then up 1, that'd be a total of only going a total of 3 units. We need to cover 6 units, so I'm just going to double that. So let's go 4 to 2. So we're going to go over 4 out of these 6, and then up 4 out of the 6, and find our point. 1, 2, 3, 4. 1, 2, 3, 4. We have ourselves a point. That point is at 2, 1, 2, 4, 5. And the lengths are separated into lengths of a ratio of 2 to 1. So from P to J is double the length from J to T. Yeah, 4, 5, that was our final answer. All right, on the next one, the line segment AC has endpoints at -1 and -3.5, and C at 5, -1. Point B is on segment AC and is located at, what's the ratio of? All right, so we have A was at -1, -3.5. 1, 2, 3. Right in the middle. -1, 3, 5. And then we have C, which was at 5, -1. 1, 2, 3, 4, 5. This is A. This is 5, -1, and that is C. And then B is on the line segment and is located at 0.2 and -3. So we're at about here. Now, do we actually need to use both X's and Y's? No, we could just use one set of them. So I think the Y is going to be easier on this one, but find the difference between the Y's. So from A to B, we have -3 minus -3.5. So that's going to be adding then. So the difference there is 5 or 0.5. Looking at the Y values on the other side, so going from -1 and subtracting off, let's see, -3. And that becomes adding. So the difference there is 2. All right. So we have a ratio of 0.5 to 2, or better yet, as a fraction, 0.5 over 2. Now, normally we don't like to have decimals, so we need to make that a whole number. How can I get that 0.5 to become 1? Double it. So if I double it, I also have to double the bottom. That's the same thing as saying 1 to 4. And that's my ratio. 92. What are the coordinates of the points on the directed line segment from that partitions into 3 to 2? All right, again, draw yourself a diagram. So we have -5, -4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Then we have 5, 1. 1, 2, 3, 4, 5. 5, 1. and that was L. That partitions, so we're looking for the point that partitions in a ratio of 3 to 1. So again, look for the change going both horizontally and vertically. So from -5 to +5, we go over 10 units. Going from the K value down at -4 to +1, that goes up 5 units. They want a ratio of 3 to 2. So what's, trying to think of an easy way to do this. All right, so 3 to 2, that's a total of 5 parts, right? So what we could look at this as, we need to go 3 out of 5 parts to the next part. So going along the one that's 5, we are going to go 3 units up instead of 5 units up. 1, 2, 3. So we have a Y value of -1. And then for the one going 10, well, if we double that, that'd be 6 out of 10. So go 6 units over from the first one. So -5 plus 6, that's +1. So our point should be at 1, -1, which is D. On 93, the endpoints of one side of a regular pentagon are -1, 4 and 2, 3. What is the perimeter of the pentagon? So endpoints one side of a regular pentagon. First thing we have to do is find the length. For which one? 92 is D. So it was right here. And we went 6 units. Sorry, not 6 units. 6. Yeah, 6 units over and 3 units up from that first point. All right. On 93, the endpoints of one side of a regular pentagon are these. What's the perimeter of the pentagon? We have to find the length between them. So we could use distance formula. Distance equals d squared of the change in the x's. So 2 minus -1 squared plus the change in the y's, 3 minus 4 squared. So we get 3 squared plus, let's see, 3 minus 4 is -1. So -1 squared. That's 3 squared is 9. 1 squared is 1. Add them together, we get 10. That's square root of 10. Now, that is one side. We have how many sides on a pentagon? 5. So that 5 times, so 5 times 10, which is option B. Find the perimeter of the triangle to the nearest whole unit. So on here, we want the lengths of these 3 pieces, which there's no real easy way to do that, but whether you look at Pythagorean theorem and distance, either one works. 1, 2, 3. So right now I'm just marking what the difference is on each of our sides. So here we go over 1, 2, 3, 4, up 1, 2, 3, 4. On this one, we go up 1, 2, 3, 4, 5 over 1. So we can do distance 3 times, or we can do Pythagorean theorem 3 times. I'm going to use Pythagorean theorem for each one. So starting with a really small triangle there, we have c squared equals 1 squared plus 3 squared. For the medium-sized triangle, I'd be doing c squared equals 1 squared plus 5 squared. And for the biggest triangle, c squared equals 4 squared plus 4 squared. Now, I will say on this last one, we could actually You find this one faster because we know that this one is one of our special right triangles. It is a right 45, 45, 90. But again, if we just plug into Pythagorean theorem, we can find decimal answers and then add them all up. So we would get, for the first one, 1 squared plus 3 squared is 10. You get 10, you got to square root both of them, so you get square root of 10, which is approximately 3.16. And for the next one, 1 squared plus 5 squared, that's 26. Again, square root both sides, you get approximately 5.09. Then you have the last one. 32, which again, that does simplify if you had done the other thing, you have got that. Either way though, your final answer, square root of is 5.66. Add those up. You get roughly 13.9-ish, which is close enough to be 14. Let's stop there. So again, Tuesday, I'll go over the rest of these. Monday, you're going to have a different thing to work on.